What was that noise?
That was sound.
What's that?
Sound is the energy things produce when they vibrate. For example, if you bang a drum, make the drum skin vibrate, which in turn causes the air molecules around the drum to vibrate as well. As this happens, when the air molecules move, this causes the energy from the drum to be spread out in all directions. After that point in time, your ear starts receiving vibrations inside it as well. Your brain then takes those vibrations and perceives it as sound. The physical aspect of sound, at least, can be represented as a sinusoidal function.
I know what a sinusoidal function is. Mr. Lime just taught us that in class today. It is a type of graph that uses sine and cosine functions and follows the y equals AF bracket k bracket x plus d close bracket plus c model. A representing the vertical stretch or compression, k representing the horizontal stretch or compression, d representing the horizontal shift, and c representing the vertical shift. So what does sinusoidal functions have to do with sound?
First off, sound waves can be represented as a basic sine wave. Sound waves are read as a longitudinal wave, meaning that you read them in a horizontal plane from left to right. If for sound, at least, we measure low densities to high densities. The first property of sound that we can measure is its frequency.
I know what that is. Frequency is the rate or number of times per second that a sound wave cycle goes from positive to negative to positive again. Frequency is measured in cycles per second or hertz. In sound, the higher the frequency, the greater the pitch, and lower the frequency, the lower the pitch.
And frequency can be used to find the k value of a sound wave's sinusoidal function. We divide 1 second by the amount of cycles to get 1 period or cycle of the sound wave. The formula being frequency equals 1 over period and period equals 1 over frequency. After we get a period value, we can graph a sound wave easily. From there, we can get a k value from the basic formula k equals 360 divided by period.
How do you find the A value then?
The A value of a sound wave can be represented as amplitude. The greater the A value, the louder the sound wave, and the same vice versa. To calculate A, or amplitude, we subtract the maximum from minimum, and we divide that number by 2.
So the sinusoidal function formula for sound waves is y equals a sine kx. Okay, class. The green line represents the basic sinusoidal function, which is y equals sine x, and the orange line is another sinusoidal function, which equals y equals 3 sine 3x. The orange line represents a higher amplitude and a higher frequency, which therefore leads to a higher volume and a higher pitch.
Why is sound even important?
Well, whether driving your car or reading in the library, sound provides you with information about the world around you. Sound serves 2 basic functions for people around the world: communication and signaling. Question: if a violin and piano make the same sound waves with the same amplitude and frequency, how come they sound so different? If the waves are identical, why don't the 2 instruments make the same exact sounds?
The answer is that the waves aren't identical. An instrument produces a whole mixture of different waves that at the same time. There's a basic wave with a certain amplitude and pitch. That is called the fundamental. And then on top of that, there's some higher pitch sounds called the overtone, also known as the harmonics. All these waves act together to give a unique shape to the sound wave produced by different instruments. And that's one reason why they sound different. Ultimately, sound can be represented through the sinusoidal function y equals a sine kx, where a represents the amplitude, so how loud it is, and the frequency to the k value.
Wow, sound is so cool.